Well, let's continue our journey as we explore the sources of water here on our amazing planet. In this case, we're going to continue with fresh water, and we're going to look at these two little slices, groundwater and then soil moisture. All right, and you've seen this picture before, so you see how small the slices are. But let's kind of zoom back out. Okay, the groundwater and soil moisture make up, look, like less than 1% of the entire hydrosphere. Okay, so this is the stuff where we're getting it from runoff, snow melt. That's where these are at, right? When it rains on land, some of the water runs over the surface of the land and feeds another water source as surface runoff. And then some of it is absorbed by the soil, and some of that absorbed water is used by plants. It gets put back into the atmosphere through transpiration. But some of it soaks into the soil and continues to travel deeper into the earth, becoming a part of various groundwater sources. Okay, so here's a just quick question. What's the difference between groundwater and soil moisture? Well, if you look at this picture, which is actually out of the textbook, right? We've got groundwater is water that's in a region of soil completely saturated with water. So if the ground is completely saturated, that's what we're talking about. Whereas soil moisture is water that's in soil that's not completely saturated, which leads us to talk about this thing called the water table. It's kind of this imaginary line that's drawn between soil that's completely saturated and soil that's not completely saturated. And depending on the amount of rainfall and things like that, guess what? Water tables do actually move. So the answer to this question is false. Now, in your reading, you came across this term percolation. Okay? And I know we percolate stuff to make coffee. Okay? But with talking about water and the earth and stuff, it's the way water moves down in the soil towards the water table. Okay? Here's a picture to help visualize what's going on. Right? So we get rain, hits the ground, and then it soaks down into the soil and passes through. Kind of like if you were to pour water into a sponge, you'd watch the water seep down into the sponge. Okay? And then they fill up these underground, think of it as underground lakes called aquifers. Now I live here in Texas, and so I found this picture of the Texas aquifers. Right? We have this aquifer along the Gulf Coast, which is this yellow thing. Right? Then through this central portion, we have this Carrizo, okay, which is another aquifer. Then this blue area, as well as this green. There's this huge aquifer kind of under the middle of Texas called the Edwards Aquifer, right? And then we've also got the Trinity that's in here, and then we've got up here in the Panhandle, we've got this thing called the Ogallala. But that's all water that has seeped down through, percolated down. Okay? So if that's a huge source of fresh water, how in the world do we get to it? Well, we dig wells. Not sure if you know, but there are actually three types of wells. Those that are dug by hand, those that are driven, as shown by this picture here, where you just take a pipe and basically pound it down in, or kind of the mechanized version of digging by hand is it's drilled. So that's three different ways that that wells are created. So here's a question for you. How fast does groundwater usually flow? Well, a little quicker than glaciers. This stuff can move 50 feet per day. Alrighty. So if you would, got a couple graded questions, go take care of those and then come on back.